In this section, we're going to step away from right triangles and look at general triangles. So we are no longer assuming that there's a right angle here. Now, when we draw the triangle, we're going to label it carefully. So the corners, the vertices, capital A, capital B, capital C, and then the sides are going to be labeled with lowercase letters corresponding to them. So little a across from capital A, little b across from capital B, little c across from capital C. We're also going to use Greek letters for the angles. So alpha, beta, and gamma for the vertex A, vertex B, vertex C. So the angle at that, the measure of the angle at that point. You will see some people in some textbooks use sign of capital A, where capital A refers to the vertex and not the angle, or actually the vertex and the angle at the same time. This isn't really worth having an argument about. Whichever way you want to do it is fine with me. So anyway, here's the setup, and here's what's known as the law of sines. Now, the law of sines creates a relationship between the sine of an angle and the various lengths of the sides. So sine of alpha over A equals sine of beta over B equals sine of gamma over C. And sometimes you'll see this flipped over as well. Okay, so what does this mean? And where does this come from? Well, this is actually, even though this is for a non-right triangle, this actually comes out of right triangles. So let's take a quick look at a picture here. So I'm going to draw a triangle here, capital C, capital A, capital B, here's beta, here's alpha. And if we take this triangle here, we can actually break it up into two right triangles. Here, and then it's on this side, and then on the other side. Let's label that capital A. Let's label this lowercase a and lowercase b. And this one in the middle we'll call h for height. And we're just going to apply some basic right triangle trigonometry to this. Let's think about sine of beta. What is sine of beta? Well, sine, SOHCAHTOA, sine is opposite over hypotenuse. The opposite is the h value, the height, and the hypotenuse is a. We can do the same thing with alpha. Sine of alpha is equal to h over b. If we take these things, we notice that there's an h in both of them. We could solve for h. So h is equal to a sine of beta, and h is equal to b sine of alpha. And since h is equal to h, these two things are equal to each other. A sine of beta equals b sine of alpha. And if we divide by a and divide by b, we end up getting that this is sine of beta over b equals sine of alpha over a. And that gets us this first one. We can take this triangle and flip it around so that the AC is across the bottom and the BC is across, and the BC is across the bottom, and get the same result. Now, in this case, we don't have any obtuse angles, but if you were to draw the obtuse angle triangle, you'll see that the same relationships still hold. It's just that the pictures look a little bit different. And so this is the law of sines. And we're going to take a look at how we can use this to solve a right triangle, or solve a general triangle. Here's an example. Solve the triangle. Here we have a 30-degree angle, a 50-degree angle, and an unknown angle. And then this side right here is known to be 10. Now, you'll notice that the vertices in this problem are not labeled. This is somewhat common, so it kind of makes sense to label them appropriately. Since we have a little b there, it makes sense to call this one capital B. And over here, we'll call this capital A. And up there, we'll call that capital C. And so that would just help us to keep this information organized. And since we're asked to solve the triangle, we're not asked to solve just one particular piece of it. We need to know all the bits and pieces. So we have three angles. We have alpha, we have beta, we have gamma, and we have side A, and side B, and side C. And so looking at the labels, we see that alpha is going to be 50 degrees, and beta is going to be 30 degrees. Well, from this, we can already figure out what gamma is, because remember that the sum of the angles of a triangle is 180 degrees. So that plus that is 80, which means we're 100 degrees short. So we can work that out mentally in this case and get the third angle. Now let's look at our triangle. We have one side, which is little a, has length 10, and we don't have little b or little c. And so here's where we need to begin. Well, so we're going to obviously grab the law of sines. Now the law of sines is pretty easy to remember. Sine of alpha over little a is equal to sine of beta over little b equals sine of gamma over little c. Notice that it's fraction equals fraction equals fraction. And at any point, we're just going to be working with two of these. And no matter which way we have it set up, when we're working with two of these, we want to make sure that there's only one unknown value. So right now, both b and c are unknown. And so if we took this part of the equation, we would have two unknown values, and that wouldn't work for us. So we're going to use set this equal to that, and then that way we only have one unknown value. So sine of 50 degrees over 10 is equal to sine of 30 degrees over the unknown value b. Now in this case, even though we know the exact value of sine of 30 degrees, we won't know the exact value of sine of 50 degrees. And so either way, we're going to have to run to a calculator and do this because there's just no way for us to do it by hand. Let's solve for b first. So b is equal to 10 times sine of 30 degrees over sine of 50 degrees. You plug that into your calculator, you're going to get a value of b is equal to 6.527. 6.527. Now, when we actually try to solve for c, we can pick either this part, sine beta over b is equal to sine gamma over c, or we can pick sine alpha over a is equal to sine gamma over c. In theory, it doesn't matter which one you pick. However, it is often best to use the given values as much as possible. This b value has a little bit of rounding error because we have a decimal approximation. And let's say we were to make a mistake. We type something into the calculator incorrectly. If we use this middle value here and set it equal to that value over there, that mistake from calculating b propagates forward into a mistake for c. And so by trying to go back to the original values in the problem, you reduce that accidental chance of having these compounding errors like this. So let's go back to the original. Sine of alpha over a, so sine of 50 degrees over a, which is 10, is equal to sine of 100 degrees over c. Now from here it's the same process. C is equal to 10 times sine of 100 degrees over sine of 50 degrees. Plug it into a calculator and you're going to get the value that c is about equal to 12.856. And so we can see the picture, it kind of makes sense because the largest angle should be across from the largest side, and that's what happened in this case. And so here's how we can solve a triangle using the law of sines.